and back and forth. So, and in that process, we may enrich some data or do something, and then back and forth. And so ideally,
yeah, exactly. That's what I was looking at.
What happens is we have an RDS database, right? And that's my AWS. That gets pumped into through Kinesis. Bus gets piped in.
But that RDS is going to go away though, right?
Well, no. It's still going to be there. Our web. It's hard to explain. I don't know. You know, honestly, they just give us it just says, hey,
You got this scope.
yeah. Say like we're working on GCP now. Now there may be a specific reason for it. Just don't slip on the ice.
It was the land.
Usually what I found is you migrate with RDS as you go into a data lake.
Yeah.
You keep
Okay, we're just gonna let the last handful of people.
you guys use
Started. Wow. So, like a full on.
I think we did. I think we
just something that gives you visibility as things go sideways.
We use Kibana. We have
So I don't know.
Okay, so you're doing log analytics.
Yeah.
Utah clustered.
That's what you got going on.
I know. I don't want to deal with the problems.
See, Lane was doing that. Our DevOps guy.
They are. Yeah, pretty sure they are.
He could probably
Change this.
Yeah.
I don't know. Just the controller on the disk.
honestly, my head has been so deep.
So remind me of the name of the company.
Citrus. ICE, I think, forward. Like Central.
Yeah.
I need for quantum scaling.
Issues with VMs doing pass-throughs.
Sounds like you're working on some
like SaaS,
forward-thinking
right?
stuff.
Yeah, it's gonna be exciting. I think what this year we're sketching to do, I think we're trying to like prove this is much more cost effective doing it this way than the current level. Right now we have huge EC2 instances, doing a lot of ETL with it. It costs a lot of development time, and also costs a lot of development and cloud costs.
Yeah.
All right.
Let's go 5 for, I think.
Okay, so this is really cool. This is really cool to see this many people show up. I think this is really close to the number of RSVPs, which is awesome. It's like Ethan is usually about half. So thanks for coming to the Utah Kubernetes meetup. Our presenter today is going to be Ethan. I'm actually super excited about it. I love it anytime a primary creator, founder of a project comes to speak, because it means we're in for like a really in-depth, we're not like queuing you up too hard here. I have a lot of confidence we're in for like an in-depth, technical, like really like good representation. And this is like near and dear to my heart because this is what I do every day of the week. So I'm gonna talk to you more, and we'll have Ethan come up and show us what's up.
Okay, so I'm gonna do it this time first. About a month ago, I got a cold and I got bronchitis from it. So if I'm coughing, it's not coronavirus. It's not even contagious anymore. That's why my voice sounds a little weird. We'll see if I can make it through this talk. Okay, so I'm Ethan. I'm the founder of Kelda. We do kind of local development for Kubernetes. I personally, when I go to meetups, find it really boring to get hour-long pitches of products, so I'm not actually going to do that. I'm more going to talk about just kind of what I've been noticing, some trends I've been noticing in the kind of Kubernetes space. And then at the very end, I'll do a little demo of something that we're launching soon, mostly because I want feedback on it. It's still early enough that if it's a bad idea, we can stop building it.
Fail fast.
Yeah, exactly. Yeah. So this is kind of a modified version of a talk I gave at the Escape conference in New York. And basically, I want to talk a little bit about why I think local development in Kubernetes is so bad. So I'll spend a couple of slides talking about why Kubernetes is happening now, because I think it informs the problems that we're experiencing in this space. A little bit about the local development problem. Then one nice thing about being a founder is I get to talk to a lot of companies. So I'll talk about the ways that I see most companies solve the problem. And then at the end, kind of obligatory demo. That's cool. I, as a speaker, tend to prefer to be interrupted with questions. I just think that goes a little more interesting, and you know, it's obviously hard to like tailor talk for the skill level of the audience. So if you guys want to go deeper on stuff, I can. And just interrupt me and go from there.
We'll yell at you.
Great. We do it along. Good. Perfect. It's way more fun in that case. Okay. So the main point I want to make, and I'll only spend a couple of slides on this, is Kubernetes didn't just happen because it's the like technically best thing to happen, right? It happened because there were some underlying human business problems that needed to be solved. And Kubernetes is the best solution given those underlying human business problems. But if people were a little bit different, or the way we organize software companies were a little bit different, I'm actually not sure that Kubernetes in particular would exist. Does that make sense? So to kind of illustrate that, I want to talk about what I think the underlying problems are that led to the creation of Docker and Kubernetes and all this stuff. And then how those problems work. Okay. So the two broad trends that I think are a little bit more fundamental than Kubernetes and created Kubernetes are continuous deployment and microservices. And I think, I don't know if we've all, depending on how old you are, you've probably worked at companies before we had continuous deployment, and it was a real struggle to get to 2-week release cycles. That was like everyone's goal at the time. I spent, this is being recorded, so I'll be nicer than normal. I spent a couple of years at VMware, and I knew it was time to leave when the executive team announced that we were going to extend our release cycles from 1 year to 2 years, right? It was a little different. They're like selling software that like is burned onto a CD and has shrink wrap and all that kind of stuff, but still. And you know, just to kind of remind everyone, we used to have QA teams who didn't write the software, and because they didn't write the software, didn't really understand the software often. And as an engineer, I would spend an inordinate amount of time trying to explain software I wrote. Someone who's like perfectly capable, but you know, they didn't write the thing. And they, you know, spend several weeks trying to write tests for the code, and then those tests would find a bunch of bugs that weren't real bugs and miss other bugs. And this was just a disaster, as a mess. So I think that's like a real fundamental problem that was slowing software engineering down. And there was really massive pressure to fix that, right? And that's why kind of CI/CD happened. We had this really big pressure to deliver software more quickly. No one said this out loud because it's not very nice, but like QA teams weren't going to be able to keep up. So we just decided to automate the deployment process entirely, right? And that is kind of the first big trend that predates Kubernetes, I think. But I'm curious actually if people like agree with that or disagree with that.
Melody agrees with you.
Okay, good. Okay, so the second trend that is really important, I'm just experimenting with putting QR codes in this. I wrote a blog post on microservices, so I'll come back to that in a second. But okay, so microservices. This one's a little weirder. If you're at Netflix scale, and even at VMware scale, the coordination overhead between teams is really big, which is why we had 2-year release cycles. Most of that time was like trying to get all the different business units to like agree on an API. And as everyone knows, kind of the theory here is that, okay, we're going to break these things up into smaller pieces, and they're going to have well-defined contracts. And as a result, teams don't have to talk to each other, and they can release independently. I'm I'm a little puzzled by this one still because I see a lot of people adopting microservices who like clearly don't have that problem. You know, like 20-person teams. And I'm a little bit conflicted on whether they're wrong and they just shouldn't be doing it, or if there's some other value, which is why I put this QR code. I wrote a blog post describing all the things that are bad about microservices a couple weeks ago that a lot of people read, and some people liked them, some people didn't. But anyway, microservices started happening. It's unclear to me why, but it did happen. And this further increases the pressure to automate software deployment because we have more stuff, right? So fundamentally, we move to a world with CI/CD and microservices where we have more to deploy, and we have to deploy them more frequently, right? And this puts a lot of pressure to automate deployment of our infrastructure. And like going back to Henry Ford, if you want to increase throughput and you want to automate, you have to standardize, right? So I actually don't think it's a coincidence that Docker started to come around around the time that like CI/CD and microservices started to take off. The value out of Docker on a 2-year release cycle with a monolith is actually not that high, you know. But if you're deploying, you know, 100 times a day, having a clean, well-defined way of packaging software and kind of managing it is a good thing. So Docker emerges. I think that's actually kind of the fundamental innovation, the idea that we're just going to like have a standard life cycle for our process, and then like, it's totally obvious that you need some way to manage more than one of these things, and a bunch of people kind of fought it out, and Kubernetes won, and there we are today. Okay, so in summary, CI/CD and microservices are why Kubernetes is happening. They created a lot of pressure to automate the deployment of infrastructure and to standardize it. And that's why we're having Kubernetes now. If we didn't need to automate, if we didn't need CI/CD and if we didn't need microservices, I'm actually not sure Kubernetes would exist because it's really complicated. And if you don't have a lot of microservices, the value is, I won't say not there, but it's less clear. Yeah. Okay. So that's kind of part one of my talk. Okay. Part two. So Kelda does local development, so I'll talk a little bit about how microservices and CI/CD broke local development. Okay. So we have this dramatic increase in complexity in production. The way we handle this dramatic increase in complexity is we introduce these really complex tools, right? So, and we're still going on this, right? Kubernetes and Service Mesh, Datadog, and all that sort of stuff, right? And the people managing production at most companies are like reasonably good at DevOps, or they at least interested in it. Now let's take a second and look at the developers who are writing that software that's going into production, and kind of the standard way that people tell you to do development for Kubernetes is, oh, you're just going to run Minikube on your laptop. So we're going to take this incredibly complicated production tool, and we're going to take developers who range from really into DevOps to I just got out of a code boot camp and I just know Node.js, right? And we're going to say we're all going to learn Kubernetes. And that just, in my experience with the people I talk to, like doesn't work. And I don't have you know, sort of formal provable numbers on this, but as a founder of a company, I talk to a lot of people about what tools they use. And of the 200 or 300 people, companies that I've talked to, I run into like 0 Minikube users. Oh, sorry, like maybe 2 or 3. And they're like teams of like 10 people who are all really into Kube, right? And then a massive install base of Docker Compose, which is what people are actually doing, which is a sign that like the local development problem is hard.
Well, sorry, just to interrupt.
Yeah.
This was something that Swarm had from day one because they had to, kind of,
Yeah.
which was transparency and support between Docker Compose locally, Docker Compose remotely, right?
Yeah.
And that was really, really cool.
Yeah.
Swarm had a bunch of other problems, but that was
Yes.
something they had from the start. They had
Yeah.
that story, partially because they already had Docker Compose on everybody's machines, but
And I think that's
kind of
great.
got left behind.
Yeah, I think Docker as a company, so I don't know anyone from Docker at the time that they made a series of bad decisions that led to their current situation. But my kind of sense as an outsider, and from talking to, like, I know some of the executives at Docker now, their DNA is so developer oriented. They're not really an ops company, right? And if you remember, like, Docker was really pitched as like, it's gonna make your development experience better in the early days, which is why I think they won in that area and why they probably lost in the production. Yeah. So, yeah. Yep.
I'd also say, like, you saying like, oh, Kubernetes is complex, but I think it's really important to note in this conversation, in the context in which we're talking about it, it's a lot like Vim, like this may be dating me, sorry, but but nobody uses Vim. Nobody uses just stock Vim.
Yeah.
It's always like somebody's got plugins, customizations, they move the whole thing, whatever, like, or they're using VI, like a masochist.
Say you're wrong, you gotta use VI before.
But they're using the same thing, even though they're talking about the same thing. Right?
Yeah.
And like Kubernetes is never separated from the context of where it's deployed.
Yep.
Like it's always got like cloud operators for like AWS or GCP or Azure or whatever. And so you're not just using plain Kubernetes, you're using Kubernetes with your favorite add-ons.
Yeah.
We're getting there. We're still not quite there.
it's more
the
like
developer experience. It's not.
Yeah.
Those add-ons don't
Which
exist.
is why it's hard to port that, because the context, like it doesn't move from cloud to cloud, let alone from like my laptop, which doesn't have that much resources to.
That's the number one problem people complain about. Yeah, I think that's exactly right. Honestly, the hardest part of Kubernetes is the network, which actually isn't harder in Kubernetes. It's just networks are hard. But and this is really not a criticism of Kubernetes. Like, yeah, to run containers at scale in production is hard, and Kubernetes is appropriately complicated.
You saw the same thing in like cloud just automation in general. Like when AWS came out, like all we're doing is taking that entire problem and shoving it in one thing.
Yeah.
So yeah, it makes total sense.
Yeah. Cool. Any other comments? Oh, okay. Okay. So let's consider for a second what makes a good development process, why monoliths have good development processes, and like specifically why it's bad now. So like basically, developers want a process that's fast. They complain if something takes 2 or 3 minutes. Weirdly, except for Java developers who are just like fine with like hour-long builds, it's always like surprised me. Ideally, it should be as similar to production as possible. I think Docker gets us a long way there, but it is a little strange to me that we're using Docker Compose locally in Kubernetes in production. And then this is something that a lot of people forget. It has to be approachable. And it is really, really easy to forget if you spend all of your time in the DevOps and Ops community, how low DevOps skill level can be. And that's not a criticism. We have a website. We have an engineer who like builds that website, and my CSS skill level is like, I couldn't write hello world in CSS, right? Engineers specialize, right? And your entire engineering team is not going to be Kubernetes experts. There's going to be people who are really good at AI or data science or front-end engineering or whatever who like don't want to learn about containers. I'm still running a lot of people like that. So it's got to be approachable. Basically, my model is there are engineers who want to open up their IDE and click run, and they want it to run, right? And if you have to do anything more than that, they're going to be unhappy. Yeah. Okay. So let's consider, as a contrast, monolithic local development. So basically, what is the kind of process like? You write your code, you build your code, you run some unit tests, and you typically run it locally on your laptop, and obviously you jump between these stages all the time. I think monolithic local development is actually a really hard problem. I used to code in C, and it like wasn't easy, right? But we've been working on it for the past, I don't know, how old is C? 6 years. I should know this. Forever, before I was born. And you know, C can only get so good, but like Node.js is pretty good. Like, pretty great actually. You like type your code and it's different. Yep.
We're on Rails Shop and we're just finally getting like all of our clients onto containers.
Yeah.
You know, I mean, just now, you know, and it's just this really big problem where it's like, great, you install A, B, C, D, E, F, G, and that's great for that developer. But as soon as you bring on somebody on board, it's just, it's like you got all these issues and problems, and you know, getting everybody on containers is just the way to go now. You know, that's my personal opinion.
Oh, sorry. So you're saying that containers helps with that problem?
Yeah.
It helps you kind of set up your environment.
Yeah, we have right now a huge monolith.
Yeah.
Rails monolith, and it's. I mean, it's got some iOS even. I mean, I don't know how that made its way into that, but yeah.
Yeah, so someone like, found like a stir coffee library in the here's exactly. Yeah.
So you make a case for Kubernetes being, or the rationale is for microservices.
Yeah.
And that's how people typically package their application as a bunch of microservices. But in an alternate world, they could package it differently, where you have a whole bunch of
Monoliths. Yeah, horizontally scaled or whatever.
Would it still make sense for Kubernetes just from a resource, you know, because the stack it, you know, deep, sell it cheap kind of idea. You're sharing it. I know you come from VMware, but
And I don't. I worked there a couple of years ago.
containers are more efficient of resources, computing resources, than VMs.
Yeah.
Indisputable. So
Yeah.
if you were gonna just look at it from, I've got so many machines, and I want to get the best utilization out of them.
Yeah.
That Kubernetes would still be your choice, or would you suggest something else?
Yeah. Okay. So I think containers are like definite, obvious win. My argument is actually we probably wouldn't have arrived at them without CI/CD and microservices as pressure to kind of like kickstart, like to make the pain of not having them so clear. I think now that containers are here and Kubernetes is here, and from my perspective, they're looking like they're going to be the standard way of deploying software.
Cost is a driver here.
And the performance cost is real, yeah. And to be really clear, I'm not a pro VMware person. Like I quit VMware around the time containers appeared.
Than VMware. So
Yeah.
if they're sitting there idle on a VM in the cloud, you're paying money.
Yeah. Well, I mean, the other aspect here, like when VMware came about, it was a big deal that I could run different operating systems on the same hypervisor, right? And it just turns out Linux won. So you just don't need full virtualization. I mean, Amazon needs it, right? But yeah, I actually think Kubernetes is probably the right way to deploy software, given that it's the sort of dominant thing, and it probably performs better. But even like performance, like if
Everything costs dollars.
but even if that was such a big deal, like why do people use Node.js? You know, like
They don't know any better.
I think I think Kubernetes is great because the efficiency of a CI/CD process where you package software, automatically gets to production, and then if it dies, it kind of restarts. That saves you like human time and is less human error prone. Like it is more performant, which is a good thing. But I'm always puzzled by like, again, like there's a lot of Node.js and it's really inefficient.
It's because it optimizes for developer time, like you're talking about, but it also like in the same vein of your question, like the optimal point is your most expensive resource getting utilized for more things.
Yeah.
And you can always throw more hardware at the problem.
Yeah.
Including Java.
Yeah.
And like Kubernetes makes some sense for saving some dollars and getting performance and saving that resources across a pool of whatever, but But ultimately, the developer time is the resource that we're optimizing around.
Right.
Yeah.
Well, I would argue, having done Kubernetes in a lot of different places, that cost savings is not the first thing you get from it at all. It's there, it's got the potential for cost savings, and you can get there, and I have, but it's gonna probably cost you more than some VMs it just will. From at the beginning, right? Like the foothold in is gonna be more expensive because doing bin packing and getting really efficient resource usage takes understanding your architecture and actually implementing things the right way to get packing. That's not everybody's use case, obviously, but
Are you saying you have to engineer things?
I do think that
I'm saying it's not like, oh, suddenly half as much cost because it's Kubernetes. Like, that's not how it works.
I do think it is driven by the need for speed, but also like I think Kubernetes is very a lot more scriptable, API driven, and like modular, and like it's easier to script it more so than I think the Chef Puppet days.
Yeah.
It's less, it's harder to create, Snowflake servers that are.
Yeah, it's more structured, so that
Yeah.
there's a million crappy chef scripts running around. But last thought on cost, like everyone is trying to hire Kubernetes experts right now. So I don't have a sense of the relative magnitude of those problems, and that problem will solve itself because we will create more Kubernetes experts.
But it's not to save money. It's because they're gonna.
Yeah, Kubernetes
It costs you a lot of money to hire a Kubernetes expert.
right.
Much more than you'd save on running Kubernetes, right?
Can I add my 2 cents to this argument? A lot of it has to do with what I've seen in companies is that it's not about cost savings, as I heard somebody else saying, it's about budget predictability. You got the bean counters who are driving development these days, and they want predictable budgets that they can plan for, and that's why AWE works.
Yeah.
It's bleeding expensive, and it's like, back in the day, nobody would have paid for the costs.
Right.
Because there was no margin.
Right.
But nowadays, you got the buzzword that everybody has to have. And then lastly, that, everybody's budget is usually spent in the first 2 weeks of January.
Yeah.
So they have to allocate all of that up front. And AWE and Docker and Kubernetes are the only ways that they can plan for all of that.
Yeah, you don't have these like $100,000 buy a million servers and rack them kind of costs. Is that kind of argument you're making? Like it's more predictable, even if it's more expensive.
Yeah. And that's all they care about because they just want the numbers to balance.
Yeah, I'm not an expert on this, but it's a good discussion. Any other? No. Okay. So monolithic development basically works. I think the main thing that changed, the reason developing microservices is harder, is how we handle dependencies in microservices is different, right? So in a monolith, a dependency is a software library. It's fixed. It has a header file. It has a compiler enforcing that you sort of call it properly. It's clear how to run it. With microservices, obviously, you also have software libraries, but additionally, you have other services which have sometimes unclear specification, and you need sort of specialized tools for running those services, right? So just basic things like when I'm writing a monolith and I need to look at the logs, it's pretty obvious what to do. If I'm writing a microservice application and I've got 5 dependencies and I need to look at the logs, like which log, right? And how do I correlate timestamps, and just everything becomes sort of subtly harder because our dependencies are other software libraries. And this really shows itself in the kind of manual testing phase of this code build unit test loop, right? All the code building and unit testing are about the same. This slide's a little redundant. When I'm working on depends on other services, so I have to specify them, get them up and running using complex production tools. Docker Compose isn't so bad, but Minikube is if you're using that. And then I have to understand distributed systems debugging, which isn't fun. Okay. So basically, the kind of world where we are is the test process of microservices is kind of crappy. It's slow, really CPU and memory hungry. People typically don't complain about this until they have like 6 to 7 microservices, and then they really complain about it. It requires developers to do a lot of DevOps style tinkering on their laptops, writing Docker Compose files and the like. The code test debug loop, particularly if you set it up improperly, can be slower for some people. Some people are like building full containers every time they want to test. There are ways around that, but not everyone knows them. It's not particularly similar to production. Obviously, if you're using Minikube, it is, but like, again, in my experience, a lot of people do. And all this adds up to something that's pretty unapproachable for a Java or JavaScript developer who doesn't care about DevOps very much. Yeah. Okay, so that's the problem. Okay, how to solve it? In my experience talking to people, like there's this kind of like journey of microservices adoption. There's this point before you've adopted microservices where I try and tell you this will be a problem, and you say, no, it's not. Like Kubernetes is great, right? And there's this point where you have like a small team working on it, and you don't notice the problem. And then all of a sudden it's a really big problem, and you feel like a bunch of pain for a while. And then if you have enough money, you like hire 10 people to solve it. So I've noticed a couple of trade-offs in how people typically go about solving this problem. I won't have like a clean answer on like what to do, other than I guess like software, which is great. But this is sort of assuming you aren't going to buy my software. What are the options? The main trade-offs are, so mocking, which I'll discuss, mock versus real dependencies, local versus remote development, and shared versus isolated environments. Those are kind of the 3 choices that you will make, whether or not you realize you're making those choices. Okay. So mock dependencies, this is pretty obvious. Like containers are hard. We already know how to deal with libraries. Let's just pretend our containers are libraries, and then everything will be great. In my experience, almost everyone like does some mocking. You'll yeah.
Mocking.
Yeah.
Microservices.
Yeah.
And we never really have really good luck with dependencies.
Yeah.
You know what I mean?
Yeah.
We're trying to do the integration tests. It's hard.
Yeah, it's really hard. Yeah. So like mocking, like there's certain problems where mocking just like is clearly the right thing to do. I find it's very rare that people have like 100% mocking. And when we do run into those people, they spend an inordinate amount of time maintaining those mocks, and it's pretty painful. So what happens, but you will run into shops who say, we just don't run dependencies, we only do mocking. And either they like push really hard to get 100% mocking, which requires a lot of engineering effort, or they just don't get anywhere near, they just don't get good test coverage. And they mock the things that are easy to mock. Yeah, that's fine. It's a choice. Yeah. Okay. The other end of that spectrum is to actually run the dependencies, right? So to run the containers, and again, all these problems that I've been stating before, it's memory intensive, and you have to deal with these complicated tools to deal with it. So, okay, that's the first trade-off. It's kind of the most obvious one. Okay, local versus remote development. Actually, so the high-level trade-off, if you're going to run real dependencies, you can run them on your laptop or in the cloud, right? And there are sort of complex reasons why you might want to do one or the other. Local is kind of the default. Like, this is the choice people make when they don't realize they're making a choice. Partially because it's most similar to how you developed with monoliths. Almost everyone I talk to is using Docker Compose.
Yeah, we're using Docker Compose.
Yeah.
As a matter of fact, I was going to ask you, like, is that a really good practice to use Docker Compose? I get mixed conflict. We had a really good DevOps guy and he didn't even like Docker Compose.
Yeah.
He's kind of against it. And honestly, I didn't even know why. I like Docker Compose. I can set up my environments and my MySQL server and a MySQL server, and I can stack them all, basically get my stack running and hit them at any time. It just, I don't know what
The developer experiences for Docker Compose is great. Like, it's hard. I don't know why anyone would have a problem.
I love Docker.
There are
Compose.
very few things that come close to what you get out of it.
Because when I have to do a Docker run, I also have to maintain the container, bring it down, or do an RM split. And
Depends on how many services you have, though. If you have to spin up.
That's the memory issue becomes a problem. So the honest answer on like whether Docker Compose is the best practice, like if I was running a company that wasn't selling Kubernetes software, I should probably start with Docker Compose. I'm running a company that is selling Kubernetes software, so we're building, right? But yeah, like everyone's doing it, like, you know, it's fine. There's several startups right now trying to build kind of the next generation of Docker Compose for Kubernetes, of which we're one. No one's quite broken out yet. So that means either we're all incompetent, or it's not a real problem, or we'll break out later. Like, it's one of those three things. And jury's out, honestly. You know, I think it's a real problem, so I'm spending time on it.
Or it's a really, really hard problem.
Yeah,
That's the later.
yeah. But, you know, if you're not an early adopter, like Docker Compose is a reasonable starting point.
okay.
Totally reasonable starting point. Doesn't require a lot of effort from the DevOps team. You can use VS Code or whatever editor you're currently using. The main downsides of this, which are like problems you either feel acutely or don't. So it makes your laptop slow. Again, like if you disagree with me, it's because you just don't have that many containers yet and keep using Docker Compose, everything's great. But you do run into people who have this problem. Again, Docker requires root on laptops. This is a huge problem for like banks, and not a problem for anyone else.
Everything's a problem for banks. They deserve what they asked for.
Yeah. And then this is honestly not a problem people complain about, but it just bothers me. Like with Docker Compose, every microservice has its own Docker Compose file, which is like maintained by these people who have just spent the past 20 minutes arguing, don't know or care about this stuff. And you end up with this like massive Docker Compose files that are like not internally consistent.
Have 20 microservices, add a single environment variable that's now required to one of them, and every other thing that talks to that microservice in their Docker Compose file needs to update that environment variable.
Yeah, exactly.
That's the scenario, and the more you get, the more it compounds the problem, right?
Yeah.
You're probably getting here, but the problem is this split. Like, I want to run some things in the cloud and some things on my laptop, and so everybody has the different split depending on what service they're working on. And so, you know.
I'd still argue that a compose file is better than any other alternative. Like, we use Vagrant and Puppet inside of VM. Take those same problems and now turn it into Puppet.
Yeah.
And it doesn't get better, it actually only gets worse.
This is why we all do Docker Compose, because I hate Docker Compose. I hate it, but I still use it because there's nothing better yet.
Yeah, like, and that's, I think, where we are with Docker Compose. Like, everyone kind of agrees that something better could be built. There are a bunch of people trying. I'm not really convinced anyone doesn't have it yet. I think we might have it, but I'm not even convinced of that. You know, we'll find out if people start using it. But yeah, it's like, there's something off with it, and I can't put my finger on it. But anyway, standard practice. Okay.
Moving backwards.
Oh. Okay, remote development. Okay, so this is the other thing I see a lot of. And the basic idea is, okay, I'm not going to run dependencies on my laptop. I'm going to run them in the cloud. There are a couple ways people do this. The kind of most basic way, that's probably the most common, is they just let developers point things at staging or production. That's some problems, but we'll get to those. Anecdotally, I will say that large tech companies with big budgets tend to build a solution to this problem internally And the problem tends to be remote development, right? And this is probably because they're large companies with big budgets and they can afford the cloud compute resources, and they have a lot of containers, so it's not gonna fit on developer laptops anyway and all that sort of stuff, right? And like anecdotally, I also think it can be cheaper just on the assumption that, as we were saying, AWS is expensive, but Apple's really expensive. And if you have a choice between giving everyone top-of-the-line laptops and AWS, they might prefer top-of-the-line laptops. But downsides of this, there's really no way to do this well without significant effort from your DevOps team.
Up front,
Yeah.
before you start writing anything.
Right. So since this is recorded, I won't say the company's name, but there was a company that I pitched our software to, and they were like, oh, this is really cool. Let me demo for you the thing we built, which was almost pixel for pixel, exactly what we had built. And it took them like 4 people in a year, which is like, but they were like big company. It was like nothing, right? Not a big deal. Requires an always-on internet connection. Like, this is the thing people complain about. I'm a little skeptical if it's a real problem.
Try living up a canyon with slow DSL.
Yeah, I just
It's redundant, isn't it? It's slow DSL.
Yes, you're right.
I'm one of these people, I don't like going outside. So maybe this is not a problem for me, but
And that's assuming like full fidelity. You can definitely do code on a laptop, on an airplane,
yeah,
in any way, shape, or form. You just might not be able to fully test integration of that code.
yeah. And I should note, there are a bunch of these cloud IDE things that I don't get at all. I'm only talking about kind of a Docker Compose replacement that's in the cloud. So you can still write your code, build your code, unit test your code. You just can't boot it on your laptop to test it in this world. I think, for most people it's probably fine. And then the last point, you can really screw up the code test debug loop with this. So you'll run into people who really drink the CI/CD Kool-Aid, and they'll say, yeah, we don't have this problem. Just whenever developers want to test, it goes into CI and it creates a little environment for them. And that is really architecturally nice, but every time you want to test your code, it takes 20 minutes. And that's too long, I think. There are ways around this, which the companies that have dedicated teams solving it do. But if you aren't aware of it, it can be a problem. Yeah. Last point I'll mention really quickly, there's also this hybrid option. I'm sure a lot of people have heard of a product called TelePresence. And that's basically, you solve all the problems of remote development, and then you additionally allow developers to run some stuff on their laptop, which they like because the tooling's better, or they're more used to it, or whatever. This is fine. I kind of think of it as equivalent to remote development, just slightly more complicated, but not too bad. Okay. The last trade-off is,
Can I just ask a question on that last one?
Yep.
I get the test loop stuff, but my question on telepresence has always been how do you know if you're doing something terribly or, right, it's already going to take, orders of magnitude longer
okay.
for your code to run?
Let's take a step back and agree on what telepresence is. So telepresence is a thing where I have a Kubernetes cluster with all my microservices in it, and I can designate kind of a magic pod, and any traffic that goes to that pod goes to my laptop, and any traffic that goes from my laptop goes out that pod. So I would boot all my dependencies into Kubernetes, and then write my code locally, and it would run there.
I'm almost 90% sure that TelePresence is fancy SSH shuttle.
That's exactly what it is. Yes. Yeah.
So it's not. Yeah, it is just.
Yeah, it's not magic. Yeah, it's a tunnel. Yeah. So okay. So what was the concern you had, or?
I don't know. It just seems to me where every call that you're doing, you're now routing in and out, and things that you expect to be 5 milliseconds are now
I see.
hundreds of milliseconds. And
Yeah, if your service is really chatty like that, it'll be really slow talking to the network.
yeah.
The code is running locally, so it's actually pretty good. The hard thing is that all the like volume setup and environment variables, there's a lot of magic that they do to get it to kind of work. It's kind of cool.
Yeah, it's cool.
I would argue your dev environment is almost performance-wise never indicative of prod, right? So like I wouldn't trust just because I run anything and it runs even remotely fast on my local dev doesn't mean when I put it in prod it'll run quickly, right? So I don't know for that.
And not all of us are writing latency sensitive queuing mechanism.
I actually notice a bigger mistake people make where they'll be like, oh, I'll solve my local development problem with TelePresence. But they don't think about like the other stuff I was talking about, which is like, you still have to figure out how to get all your dependencies and how to put them on a remote Kubernetes cluster and who's going to run that remote Kubernetes cluster. But happens like, that's the hard part. Like if you solved all that, like you'll boot TelePresence and if it's slow, you'll like move to an AWS data center that's closer to your office. And if that's still not fast enough, you'll like create a staging environment.
If I remember right, my biggest problem with TelePresence was the story for multiple services was never very good.
Yeah.
Right? They kind of like, oh, you want to do 2 local services? Hold on, like we can't have that.
Or if your pod has like sidecars or multiple containers in it, it just, goes.
So it works really, really well and it's really good for a percentage of people, right?
Yeah. Again, anecdotally, and I'm talking to a particular segment and type of people, I don't see a lot of TelePresence usage. It's cool.
Academically, it's a cool idea.
Yeah, it's really cool.
Yeah.
Well, it seems like when it works for simple things, it's really cool.
Yeah.
It's a very niche thing.
That's pretty much all the solutions we have for these kinds of things.
Yeah, I know. Yeah, it's really frustrating.
They're all just like, this is my simple case and I've solved it this way. And it's like, okay, that doesn't apply to anyone else.
I'll note also frustrating is someone who's building products, like people don't want like broad solutions that solve 12 problems either. Like it's really hard to get this adopted. So like all the incentives are set up to like build really niche solution. Yeah. If anyone is interested, when the cameras are off, my background is in networking, and I can give you a very long tirade on why Istio is not as good an idea as they think.
Oh, you could do that. We got lots of recordings.
Yeah. Can't watch any of our previous Istio discussions.
Okay.
We're okay with Istio.
Yeah.
They can exist.
Okay. Can exist, and maybe someday someone will use it. Okay. So, the last piece, again, this is like a choice everyone makes and not everyone realizes they're making, is shared versus isolated environments. Are my dependencies shared by all of my developers, or does each developer have their own kind of collection of dependencies? So shared, okay, actually, I'm going to talk about this in the opposite order. So, isolated environments are probably the easiest to think about because that's what you get if you're kind of running on your laptop. It's harder to do with remote development, particularly if you kind of do the path of least resistance where you just have everyone use the staging environment, right? Again, these companies that have dedicated teams to solve it tend to do remote isolated environments, but there's not really good tools for that right now. Shared environment is exactly what I was talking about. Like there's a Kubernetes cluster and everyone kind of pings the dependencies, and you run into problems like, and I've talked to people who have problems where one of their coworkers deploys to, pushes something to Jenkins, and every time Jenkins deploys, it restarts all of the containers in the environment. So something totally unrelated to what they're doing is calling, it can be a mess. It can also work fine. But anyway, that's another trade-off. Okay. So in short, there are like 3 high-level trade-offs that people tend to make: mock versus real dependencies, local versus remote development, and shared versus isolated environments. And my sense is that as people get more mature with Kubernetes and have the resources to build it, if they have the resources to build it, where you kind of end up is honestly, both mock and real dependencies, but at least some real dependencies. Remote environment and every developer having their own isolated thing. I think that's kind of where people would like to end up, but I think it's kind of hard to get there with the current tools. So in practice, I'm only seeing like, best funded giant companies doing that.
Well, going back to cost, that is the most expensive permutation of those options, right?
Yeah, exactly.
It is going to be the most duplicated work and the most resources they have.
Most work, most resources, and yeah, exactly.
Tooling and actual machine.
Yeah, exactly. Okay, cool. That's kind of like the theoretical part of my talk. So any questions on that before I move on? Nope. Yep.
Sorry if this is too basic question, but what is a mock dependency?
Oh yeah. So most programming languages have a mechanism where, like, suppose I depend on a microservice that's a calculator, and I can send requests to it that are like add 3 + 5 or whatever, right? It's calculator. Okay. And in production, that would be handled with a REST call. So like my microservice would, open up an HTTP request that thing and say, please add it. Locally, I would mock out that dependency. So I would write a software library. I would write a program that says it's the adder microservice, but really when you call it, you're just doing a function call, right? And then it would like do the thing, and then return a result. And all of this is kind of compiled in, so I just don't have the problem. You'll also see people have like mock microservice dependencies, like they'll build containers that are kind of like a mock of a database. But yeah, that's the approach. It's generally a good idea to do at least someone. Yeah. Any other question?
And I'll just throw on top of that. Like, it sounds trivial in an ad, like 3 + 5. But a lot of times it's not even smart enough to do anything. You tell it in advance. You say, okay, when I send you a call, you return 8. And that's all it does. And you just say, okay, I want you to return in this order 8, 14, 27. And then that lets you test the business logic. And it didn't actually need to know how to add. It just returned some hard-coded response.
Some people do duplicate the code, and that's.
Why would you?
I've never done that.
What occurred in one company recently was somebody had mocked out all the functions in a module, and it worked perfectly. Module didn't install. They never wrote a test for that.
So in short, good idea, but you probably should test other ways as well. No. Any other comments? Okay. So I hate going to meetups with vendor pitches, so I'm going to keep this like super short, but I'll tell you kind of what we're building. We have like a product, and then we have something that I'm building that I'm actually more curious about feedback with. So I'm going to demo the new thing, and I'll spend like 1 slide on the product. So basically, we notice this collection of problems, and we're trying to solve it. Kelda is kind of Kubernetes development environments. That QR code just takes you to the homepage, kelda.io. Quite selfishly, I said you want remote, isolated, real dependencies. That's Kelda is that in a box, right? And we decided to build it because we noticed all these people building essentially the same thing at these well-funded tech companies. And we're like, we know how to build software, so we'll try it once. The basic way it works, if you're a company and you have a bunch of developers, you have your production Kubernetes cluster, you have your staging and Kubernetes cluster. You're going to create a development Kubernetes cluster as the DevOps team. The DevOps team does that. And then a developer, it has an experience a lot like Docker Compose with a slightly better UI. So they sit down on their laptop, they do Kelda run, all of the containers they depend on boot up on that Kubernetes cluster in their own isolated namespace. And we do kind of telepresence style networking magic so that it feels local. So they kind of interact with it over local hosts. They use the editor that they're used to. They aren't really aware of any of this stuff. So that's what Kelda is. If you have kind of a team of people that are building microservices, talk to me. It's sort of interesting. Okay. Any questions on that before I move on to the thing I want to demo? Yeah.
Is it a Docker Compose file-like experience, or is it a custom resource definition experience?
Yeah, okay. So the thing I'm going to demo next is a Docker Compose file-like experience. Kelda, you configure it with standard Kubernetes YAML. So you have your production Helm charts. You have a version of it where you say, instead of running 12 of each container, run 1 of each container. And we kind of pull that from a Git repository and boot it for you. Yeah, but it's not, it's sort of morally equivalent to Docker Compose, but it doesn't read Docker Compose files. Yeah.
Different values for all of those things, basically. You only support Helm?
We support like Kubernetes stuff. So raw Kubernetes YAML, Helm, case on it. You can hand us a bash script and we'll run it and run on whatever the output is. Yeah, fair enough. That was popular. Yeah. Cool. Okay. Well, that's great. Check it out. Okay. So this is the new thing we're building. This is the code name for it, which someone else came up with, and it's growing on me, but we'll see. So Kelda Forge is basically this, very similar to Kelda. It's a drop-in replacement for Docker Compose that runs in the cloud. Okay, so you solve this thing, you run Kelda Forge up instead of Docker Compose up, and it boots all the dependencies in the cloud, but volumes work, networking works, all that stuff works. So it's really aimed at people who are having the problem of too much stuff on my laptop is taking a lot of resources, right? With Kelda Forge, it runs in the cloud, so that your laptop isn't eating up all those resources.
Can you choose like if the volumes are in the cloud or on your machine, or like how does that?
So it works the same way a Docker volume works. You have a folder on your machine and a folder in the container, and it kind of like syncs them together so that whatever's the same thing. Yeah. So this is kind of a new thing that we're working on right now, still under active development. And really what I'd like to do really quick is demo it and then get feedback from people after the talk is over, if that's okay. Yeah.
You've come to the right place.
Good. Okay. So it's a drop-in replacement for Docker Compose. It runs in the Kelda Development Cloud, which is just like my cloud on AWS. Volume ports, I already said all this stuff, so I'm just gonna jump into the demo. Okay. This is like under very active development and has literally never been demoed.
Well, we heard you were good at CSS at the beginning of this. So.
You go well.
Yeah. Demos do. Yeah, okay. So step 1, figure out how to show you a terminal. Success.
Whoa. Wow. You're like one of the first people to ever have a large enough font.
I was warned. I was warned before the talk. Okay, Magda is one of the many ways the Australian government wastes money. They have this very complicated microservice open source application for searching government data, which is like vastly over-engineered. But it's open source and it has actually very typical architecture, so I like to demo it. Not written by us. This is a Docker Compose file which describes how to run Magda. And blah, blah, blah. I think Travis has basically seen this demo before, but so instead of doing Docker Compose up like I normally would do, I do Kelda Forge up. Cross fingers. Okay, cool. And it pops you into a UI that is basically quite similar to actually the core Kelda UI. So we've got all of the different kind of containers that were specified in the Docker Compose file. Those are all booting we're using Google Cloud. So booting a Google Cloud instance. And then the sort of network traffic is set up so that
In GKE or like actual just VM?
So again, this is under heavy development. So this demo is a VM. If that makes sense.
Yep.
But like we'll probably shift over to GKE. Yeah.
And it's just talking to the Kubernetes API, or is there another level of access that you have?
So the goal of this product is that you can do everything that you can do with Docker Compose and not a lot more.
Okay.
If that makes sense. So if you want access to the Kubernetes API, you should use Kelda, which actually gives you Kubernetes. The big issue with Kelda we found is that it's individual developers often really struggle to like create a Kubernetes cluster, which is a requirement for Kubernetes. So the hope is that this is something that they can just like download, point at their Docker Compose file, and solve the like performance issue if they're having it.
Gotcha.
That's yeah. So anyway, this is booting. That's a GitHub repository. This is way too small, but you don't really need to see anything on this thing. But if you go to localhost, it's actually tunneling the traffic to the Docker Compose instance that's running in the cloud. Volume mounts will work, all that sort of stuff will basically work. It's like literally a drop-in replacement with a slightly prettier UI. Yeah.
So when you say all those work, the difference between this and like a Docker machine, which would also work,
yeah,
is that you're doing the same local sync of my file system and any changes I make to my code into that target container, or
I think we're using Docker machine, gross.
it's a socket, just like a
actually, the functionality difference is not that big. Docker machine requires you to like have the credentials to like boot a VM in AWS or whatever. It's also super painful.
Well, I mean, it's essentially, instead of talking to a local socket Docker, you just have an ephemeral TCP socket Docker somewhere.
Exactly. Yeah.
But you're still doing more fancy stuff in volumes, because like them, if you Docker machine something and you mount a local volume, you're mounting a local volume on that remote machine. Is this still saying I get access to my local files, but in that remote?
Yeah, I mean, again, under development, like, we're really confident that we can make it work, but who knows? The aspiration is I mount a volume using the standard Docker Compose syntax. There is a file, the folder on my laptop that appears in that remote thing. That makes sense.
And that's not Docker machine. Docker machine will not do that for you.
Oh, okay.
Because Docker machine, it sends the commands, and then those commands are going to mount against its local, like whatever.
You're just talking to remote naming, right?
Yeah,
like,
you're just talking to remote naming.
Yeah, it has no.
Yeah. So there's some implementation risk here. We have like a half-built version of this where you can. I don't want to get into it because it's half-built. But anyway, that's the high level. That's the aspiration. It's at the point where, depending on your setup, you can start playing around with it if you have access. And I will, there's a QR code, but it's just kelda.io/forge. There's kind of a wait list. So if it's something that's interesting to you, sign up for that wait list. And I'll also give my email and like email me and tell me you were here and I'll like bump you up. But let me kind of like actually switch back to presentation mode.
Would you say this is a subset of Kelda? Does it have features that Kelda does not?
Yeah, it's a subset of Kelda. Okay. The features that this doesn't have, the Kelda, so there's the two sets of features. One, Kelda won't currently like take a Docker Compose file.
Oh, sure. Okay. Yeah.
And then the other issue is if you're a team wanting to deploy something for like, you need multiple people on the same Kubernetes cluster, you want it to run on your Kubernetes cluster versus on my Kubernetes cluster. you want to be able to pull configuration down that is similar to what you're using, like your Kubernetes YAML from production. Does that make sense? So that's like the stuff, it's like business stuff is what Kelda does, if that makes sense. But the actual user experience will be very, very similar. Over time, we're going to change the command line interface. So it's like the aspiration is to be able to like literally alias Kelda, Docker compose equals Kelda forge, and it will work, if that makes sense. That's where we're kind of headed with it. And the hopes that it's useful, and then, you know, 5 people are using it at a company and go to their boss and be like, hey, buy the real thing. That's the goal. There's one more slide I want to show. And I'm basically done. So I'm going to like show this slide and then take questions. Okay. So if you're interested in that QR code will take you to the wait list and you can email me. Yep, and I'm done. So go ahead.
The biggest problem that we've had, we have had is we do everything in Go, like a lot of people here. And so it's not as simple as, oh, I'm just syncing this one 2 kilobyte file up to the cloud. It's just, we ship a scratch Docker container, so it's a 40 meg push anytime that something changes. And so it feels to me like most of the developer tooling is focused on and is good at that dynamic.
For like, you mean like for JavaScript and Python and all that?
Right.
Yeah.
Where for us, that feels almost just as fast to just go ahead and push to an image registry. We use scaffold.
Yeah, yeah, it's partially like a segment thing. Like, again, like the people I'm talking to don't really use Go, mostly because they're like they're not into Kubernetes to the degree that they're like showing up at Kubernetes meetups and all that sort of stuff. So we're mostly seeing JavaScript, Python, Ruby, Java. And anyone who's like doing Go development probably knows about this stuff, honestly, that they like scaffold will work for them. I would be curious, and maybe we can talk about it out again. I'm curious how big your actual Go binary is.
They're about 40 megs.
Okay. Yeah, so your like container is basically nothing but the Go binary. Yeah. Yeah, I mean, like you could do something where you sync over the files and then compile remotely. Obviously, like one annoyance with Go is people are working on Macs and running on Linux, so you gotta let's deal with cost. You know, like basically, all right, you know, that market is small enough that
that none of the dev experience companies are tackling.
Yeah, exactly. I mean, a lot of them do actually because they like Go. We work with Go, and we have people using Kelda who do Go every day, but it's not like the Go features aren't at the top of our list.
Right.
Right. Yeah.
Saw somebody trying plugins on it, like hot reload your main function via a plugin, but it never really went anywhere and was riddled with all the problems that Go plugins have.
Yeah. Yeah, that's, you really want that.
I think there's also approaches that try to just go run instead. So like instead of syncing over the whole thing, you're just assuming the thing you're remotely doing was doing a go run instead of a whole build anyways.
Is it that bad to like, I mean, I don't know.
It's not terrible, but we've got just a bunch of, you know, dirty containers that, you know, don't sync to a commit anywhere.
Yeah.
Well, the recompile's fast, so it's not like you're doing C++ or something.
Right.
You can probably get that development loop compiling remotely very quickly.
If you have a warm cache on the remote side, your compile loop there is going to be pretty fast.
Yeah.
Like I'd say we're currently 30 to 60 seconds to it running in Kubernetes.
Yeah.
I imagine for most of the companies you're talking to that have Go developers, like just having the standard tools that they can work across teams and whatnot and fill that same workflow is probably good enough for them. Like they don't know any better and don't have like strong opinions like about that workflow at this point.
Yeah, and I just found like, like I love Go. Like Go's great. Okay. But like it means something that I love Go because like I like a lot of the people in this room are like into this stuff. And I think Go tends to select for people who are like really interested in their tools and want to learn how their tools work and all that sort of stuff. And like, you know, those people, if I tell them, oh, local development's really hard, like, you know, like, no, it's not. You know, like it's fine for them. So I think if someone becomes the standard way to do this, all the Go developers will use it just because it's the standard way to do it. But the pain isn't as acute for Go developers in general. So it's fine.
Well, we're pretty fortunate with all the Go upgrades to not have to constantly reconstruct our code to have it continue to keep compiling. Like Ruby is the worst for this. I felt like as soon as I wrote anything in Ruby, there was a new subversion and they had changed the way a bunch of things worked and it just didn't work the same way anymore. And
I mean, but some of me just misses I hit edit in FileZilla on the PHP file and it syncs it and it's like running within, you know, a second.
I grew up out of C, so.
I did that with APIs.
I mean, no one would do that in production.
Maybe you didn't understand this, but are you actually like, would you run the binary locally, or is it just that your files are, it's the actual process is running in Kubernetes, but the files are local?
For Go development?
No, for Kelda.
For Kelda, it's running in the cloud. So you're developing
it runs locally. It's just that the files are local and the fault payments get synced.
So the normal use case to think about is Java.
Just TelePresence, it's running locally.
Yeah.
Network management.
Yeah.
Okay.
Yeah. The example to think about is like Node.js, right? You edit your files locally. They sync.
Rsyncs up to or something.
Yeah, it's fancy rsync. You know. Rsync doesn't work for various reasons, but it's like effectively the same thing.
So for like him, it's easier just to rebuild the Go binary and push it up to like a new pod.
Yeah.
Then.
Yeah, and
because it's not running locally, it's not like any faster.
Yeah. And for the people that we have using this that are using Go, they just sync over the binary. And you know, there's something nice about that because you probably run unit tests and other things anyway. So the binary shows up on your file system a little bit before you're ready to test it anyway. But like, again, it's like you're saving, you know, 5 seconds. It's not determinate, you know, it's not huge. Yeah.
Yep. So I'm curious, I have a problem in many of these scenarios where I'm doing Docker Compose or even Kubernetes stuff. And I haven't seen a good approach to all of the space, I guess, not necessarily competitors with you, but
yeah,
curious what you have done. Kafka is my go-to example for this.
Yeah.
Kafka has to know what it's called.
Oh, yeah, sure.
So DNS-wise, I'm going to connect to a port, and it doesn't matter. I just connect to an address port, and then I get told by Kafka, that's very cool. Come talk to me at whatever address.
Yeah.
That's how
do you
it still
handle
works.
Yeah.
To be fair on Kafka, that's by design, right?
Yeah, they chose architecture that was stupid long ago. I understand.
Yeah, okay. So like the original sin here is port forwarding, like, which is just a mess. And I'm a networking person that like really bothers me that that's how they do it. Interestingly, most people don't have that problem. So we haven't built it yet. Like I wanted to solve this problem internally, but my co-founder has prevented me from doing it because it would take a long time. But where I want to go, Kelda, this is kind of a feature on the roadmap, is every microservice has a host name that is,
Or at least every service does in Kubernetes. Right?
Yeah, every service has a host name that is unique to you. So it would be like evilcorp.ethan, I'm going backward, but evilcorp.ethan.beevil microservice, and that's what you would connect to, if that makes sense. And that would be totally consistent every time. It's like not hard to do from a networking perspective. The hard thing about that is explaining to people that they need it and why they need it. like it's a hard marketing problem. Like I've tried to get people excited about this so many times, and you're like the first person who's ever like gotten it. So in the short term, we just like port forward, and we're no better than what you're currently doing. But that problem's solvable.
Yeah, I mean, there's tools already. Like I just use ngrok at this point because and as long as you have a consistent name, you can just tell it. Yeah, it's my name. I understand. I'm with you.
I'm also shocked by the number of people like running Kafka and Docker Compose.
It's not by choice.
It works fine. It works totally fine as long as you run exactly one instance.
Yeah.
Right. And then you're not doing any of the things that you do in production, like encryption or ACLs or like that. You know, it works totally fine. Local dev.
Yeah.
It does not translate at all to production at all. Not, sorry, that's a.
No.
Go to your happy place. Go to your happy place.
Okay. All right. I'm going to stick around until my voice gives out or I'm the last one here. So if people want to talk to me directly, I'm here. And I really appreciate being invited to talk. Like, it's fun for me to do these things and having really a lot of people here and really engaged in good questions. So that's awesome. So thanks.
All right. Paul was here. We'd give out stuff, but I don't have any of the.
I have the stuff.
You have the stuff?
Yeah.
All right. Derek's got the stuff.
Give them stuff.
How are you going to do the drawing?
Random.org has a calendar picker. So in Paul's honor, I'm gonna hold it like this and just click it blindly a number of times. So closest birthday, either direction. 2, refreshing, March 29th.
Got something close to March 20th. January? Anybody got?
May.
May.
March 14th.
10 days.
March 14th.
You should have spoke up earlier.
Yeah.
28th.
March 29th.
Yeah.
March 14th is closest.
Yeah, absolutely.
Anyone closer than March 14th?
Okay, there you go. There you are.
All right.
See, Derek, for your free brains.
Okay, now there's 2 of them. So I got one more. August 26th.
September 3rd.
July 13th.
July 30th.
May 26th.
Put it in.
What?
May 26th?
Yeah.
Legitimately, no one's closer than September 3rd?
That's only 5
That's pretty close. Yeah.
Sorry. I thought I said September 29th.
All right.
6th, whatever. Okay,
Okay.
all right.
Here we go.
Come see me afterwards and I'll send you over your code.
I think there's still plenty more food, so feel free to have seconds. And
But not if you want Chick-fil-A sauce.
yeah. Okay. Other than that, we all kind of stick around and have discussion afterwards. So thanks for coming. Chick-fil-A sauce. To eat your poor slaughtered animal without talking to you too.
You eat Chick-fil-A, but there's no Chick-fil-A sauce? Was it really Chick-fil-A?
What's the recording? I guess we do. 8 times that. Yeah, thank you for reminding me.
See you at the next car.
Yeah, see some info on that. And like I say, I'm watching the 2 around looking at